All right, today we are factoring trinomials again, but we are adding an extra kick to it where there's going to be more than one letter, possibly. Okay, so the problems look like this. Number one, where you have an x squared at the front and a y squared at the back, or vice versa, or any letter. It doesn't matter what the actual letters are, but there's two of them. Okay, they must follow this pattern in order for factoring to actually work. So you have to have the squared in the front and the back, and then no squared in the middle. Okay, front and the back, and no squared in the middle. It's the only way that this will work. Because it's the only way it'll work. I don't know what else to say. Okay, but the process is still the same. This looks very intimidating, right? It looks very intimidating. So the problem with that is it's ugly, and it makes it much harder to look at and actually factor. So one thing that we can do when we're factoring these is to forget about the second letter. We'll add it in later. So in other words, we're going to factor this problem like this. So totally get rid of the second letter. Then we factor this, multiply 8 times c, get 8. Two numbers, this looks like the same problem from yesterday. Multiply to 8 and add to -6, so -2 and -4. Put x's on those guys, blow up the middle. And we get -2x, -4x. So we're just factored by grouping. Excuse me. So this is just from yesterday. This is nothing new. You had a problem with that. You can watch that video. Now, what do? Well, good question. What we do is we simply replace the y where it belongs. And it belongs in the second spot, here and here, the y and the y. Okay? You can do this whole problem with the y squared on there, but it does get a little bit confusing. I'll prove to you that it works. Remember, we're unmultiplying when we factor. So I'm just going to do a quick multiplying to prove to you that when you just put the y on there, it works. Here we get x squared, -2xy, -4xy, and +8y squared. So you can see that -2xy, that's what we have here. We could have left the y on, but it gets very confusing. So instead, we just factor it normal and plug the y on after. So we get the x squared. These two are like terms. And then we have plus, oh, nice bears. Yeah, that's how that works. I can add. Excuse me. There we go. Okay, -4y, xy, and -2xy. Sorry, that's my son. Anyway, this is the answer, or the question that we got. Now, this is the factoring piece. Let's change to purple here. This is the factored piece. This was just what we would call the check. Okay, you don't have to do that every time. It's just what we're going to do. I just did that to prove to you that it works. Okay, nice. Okay, so this problem here. Now, first of all, it's got x squared, xy, y squared, so we're good. But I do see, because, sorry, I accidentally turned it off. I can see that all of these terms are even, so there is a GCF. So the best idea is to factor out a GCF. So factoring completely involves, factoring completely. So we're going to factor out GCF first. X squared plus 13xy minus 30y squared. If you do factor that GCF out, it does make it a lot easier to factor. Like finding, if you multiply 2 times -60, you get a -120. It's going to take a lot longer to find two numbers that multiply correctly. Right? Right. You know what I'm saying. All right, so this 2 needs to be in the answer. It has to be in the answer. So what I like to do is I like fake my answer out right now. I'm like, I'm going to write my answer here, and this is what it's going to look like when I'm done. That 2 is there. All my other work will be on the inside, like in between those 2 things. So we get negative 30, 2 things that multiply to negative 30 and add to negative 13 would be 15 and positive 15 and negative 2. So we're going to slap X's on those. Oh yeah, because I'm ignoring the fact that there's a Y here. I'm getting rid of those because it looks confusing. And if that confuses you, please do this. This is definitely a method that's 100% acceptable. So we're going to factor out the GC. We're going to blow out the middle here. So 15x and negative 2x. Bring the 30 and the x squared down. And now just factor by grouping. Factor out an x plus 15. Then we have that negative here, so that's negative, and GCF is 2. So factor out a negative 2. We're left with x plus 15. So x plus 15 goes in one of these, and x minus 2 goes in the other. Now, you do have to remember that there is a y squared in the problem, so you do have to plug that y back in. But the worst thing that happens is you lose a point or so. It's not that huge of a deal, as long as the factoring piece was the important part. Okay? Alrighty. It happens, you know what I'm saying? All right, this one here does not follow the pattern. We have a cubed here, we have a squared here. This is just all seems wrong. So that should be your clue that if this is factorable at all, that there's a GCF. So since a is in all of these terms, I'm going to factor out an a. Same process as with the 2. I'm left with a squared minus 3ab minus 28b squared. Now that looks correct. We got the 2 squareds on the outside, just the multiplied on the inside, but we have this GCF. Write that so you don't forget it. You know, I'm just trying to help out. All right, so we're going to pretend like the b's aren't here, and we'll run this problem through. So it's just negative 28. Multiply to negative 28. Add to negative 3, so that would be 4 and negative 7. Blow out that middle. Plug the a's on. Factor by grouping. A plus 4, and negative 7, a plus 4. So a plus 4 repeats, and a minus 7 is on the outside. That goes in the other one. Make sure you plug the b back on. Okay, so there's our answer. All right, I hope you have a wonderful day, and see you tomorrow.